Hello people, welcome to today's class. In today's class, we are going to be looking at something that is very fundamental. We've started the analytical series for the semester, that is Chem 241, and we are going to take the topics one after the other. Now, in this class, we are going to do a brief introduction. Let's go. Okay, welcome back. Now let's look at the brief introduction of analytical chemistry. Now, the first thing that you must know are the problems that are encountered by analytical chemists. Analytical chemists often encounter two problems rather. The two problems are the quantitative problems and then we have the qualitative problems. As the name implies, the quantitative problem talks about the amount of an analyte in a sample. The quantitative problem talks about the amount of the analyte in a sample. Then the qualitative talks about the presence or indicates the presence of the analyte in a sample. For instance, if we want to get the amount of boron in distilled water, now you should know that the presence of boron in distilled water often causes damages to the manufacturing of electrical parts. So in most cases, when you want to use water in the manufacturing of these electrical parts, it's often recommended that you test for the presence of boron. Now, if you've tested for the presence of boron, sometimes it may be negligible, like the amount of boron present is small. That is why it is often required that you do quantitative test. Now, the quantitative test is the most important of these two, because the quantitative test can do the work of both the quantitative and the qualitative. The quantitative often represents whether it is present or not, and the qualitative and the quantitative also tells us the level or the degree of it in the sample. So that is basically the two types of problems that are encountered. We said we have the quantitative problems and the qualitative problem. The quantitative tells us about the amount or the degree, the level of the analyte in the sample, while the qualitative problem tells us what the present. So in most scientific experiments, in most cases, the quantitative problem or the quantitative analysis is often carried out, not the qualitative. Why? Because we have already established that the quantitative can also give us information about the qualitative problems. Now, in carrying out quantitative analysis, you cannot write quantitative measurement without actually describing the error that is inherent in them. You cannot write quantitative measurement without describing the error that is inherent in them. For instance, let's say in the discovering of a new laboratory reagent, previous experiments has gotten values from 1 to, let's say, 100. Then you did your own measurement and you got, let's say, 104. This value of 104 is not accepted, or it's of no significance until you've stated the error that is inherent in it. I said the value of 104 is not accepted or significant until you've stated the error that is inherent in this measurement. Let's say 104, and the error is an estimate of, or the estimated error is plus minus 2. If you do this mathematics, this 104 plus 2 will give us 106. Then 104 minus 2 will give us 102. Now, having stated the errors that are associated with them and even using the error in our calculation, we discovered that the values are still greater than what? 100. Hence, a new reagent has been discovered or has been invented. But whenever, or let's say in a situation where your estimated error is now plus minus 10, if you do the calculation here, with the error, you have 104 plus 10, which is 114, and the other is 104 minus 10, which is 94. So this one is not what? Accepted, because this one falls under the range of 1 to 100. So you see that the error associated with a measurement will actually tell us the degree of significance of that measurement or not. That is, if the measurement is significant or what? Not. If the error in the measurement, after calculating, and you see that it falls within previous one, then you said it's not what? Accepted, or it has not been what? A new reagent has not been discovered. But if it falls outside after the error, then you said the new reagent has been what? Discovered. This is just for this analysis. So that is basically it for quantitative problems. Measured value is what is called errors. Now let's discuss the types of errors. We have three basic types of errors: the gross error, the random errors, and the systematic errors. As the name implies, gross errors are those errors that are so big that you have no option than to start the experiment all over again. That is, they are not repairable. You cannot adjust them to actually just manipulate your way through the experiment. You have no option than to start the work again. Such kinds of error are known as what? Gross errors. Then, examples of gross errors are: 1. Obvious breakdown of a laboratory instrument. Secondly, is when you actually think that a reagent is pure, only to discover that that reagent is impure or obvious or badly contaminated. Such kind of error is known as what? Gross error. Another is when a reagent is what? Carelessly discarded. Such kind of error is a gross error. So that is basically it for gross error. That kind of error that cannot be repairable, that you can't manipulate your way through, is what is called what? Gross error. For example, when somebody said, I've made a gross mistake for doing this, that means there is no turning back. It has happened, it has happened. You have no option than to start the experiment all over again.